Hello everyone. So we're going to talk about the data science course today. A specific topic I want to discuss for today is about the theoretical probability distributions. It's a material for week 3. Okay, in these lessons, we aim to achieve the understanding of preparing the data for exploratory data analysis. From statistical point of view, there is a quote which says, "It is easy to lie with statistics, but easier to lie without them, because data prove everything." Statistics can help us to draw conclusions from some problems happen in the populations. From big populations, we can draw a small subset of them using a certain probability, and we call this subset as sample. Then we perform some descriptive statistic, and then from this small sample, we can draw some inference, which is called inferential statistics, to draw a conclusion for a bigger populations. Think as a statistician means we need to remain vigilant and careful not to over-interpret, while we also need to retain the confidence to analyze the data to come up with a conclusion. And why do you think a data scientist needs these skills? Because most of the time data come from an unknown size of populations. We are unable to count everything in this world. That's why we need this skill to at least properly estimate the outcome for bigger size of the data. For example, as a mobile app data scientist, during an A/B test, we can draw a random sample of all users who installed the mobile app, and we can quantify the probability of a user coming back after 1 week of the user installing the app. There are two types of most common used probability. For discrete data, we have binomial distribution. And for continuous data, we have normal distributions. So today we're going to discuss about these two distributions. Okay, now about the binomial distributions. B means two, like a bicycle has two wheels. So this is about things with two results. For example, when we tossing a coin, did we get head or tail? We say the probability of the coin landing H is half. Also, the other side, the probability of the coin landing is half as well. Okay, how about the throwing a die? Throwing a die has 6 faces. How about that? So we can say the probability of a 4 is 1 over 6, and the probability of not 4 is 5 over 6. Note that a die has 6 sides, but here we look at only 2 cases. Is it 4? Yes. Is it 4? No. So whether 4 or not 4. Okay? So this is the example of tossing a coin 3 times. H is for head and T for tails. We can get any of these 8 outcomes. So we have combination of this H, H, and H. So head, head, head. 3 coin is all head. And then we will have 2 head and 1 tail. 2 head and 1 tail. 2 tail and 1 head. Okay, and etc. So what is the probability of each outcome? Each outcome is equally likely, and there are 8 of them. So each outcome has a probability of 1/8. So the probability of even of 2 heads is 3 times 1 over 8 equals to 3 over 8.